So good morning. Today we are going to continue with the topic process. So this is one of the important concepts of operating system. Usually when we develop a program, we develop in a high level language. That is the language which the user understands, and that will be converted to the lower level language. Only then it will be understandable by the system, and it will be ready for execution, right? So such a procedure is done by the compilers that we have already installed in our system, and only when it gets converted, that alone is not enough, because after the conversion transformation from the high level to low level language by using a compiler, that program, it must be loaded into the main memory, and then it needs to start its execution. And also, even with that start of execution, the process doesn't get its complete resources. So all the resources that are needed by the process, it should be supplied to it for betterment of the execution only by the underlying operating system. So all these must be happened parallelly, only then we can get a proper result. So such a program, so when we just write a program for doing a particular task by a computer, so that is just a program which is a passive entity. So which colloquially we can mention that it has no life. So only when a program is starting its execution in the memory, it will be converted into an active entity, which is nothing but a process. So such a process will have many resources associated with it, and also many criteria and many states. It has to pass upon many states, so that we are going to discuss in this lecture. So before entering into what are the states of a process, first of all, let me show a real-time way in which you can see the processes in a particular system. This is a task manager. So here, what are all the processes which are currently running in the system, it is being shown here. So for example, the video recorder, and then the Chrome, Firefox. So these are, and also you can see for a single program, or a single application, you can have n number of processes generated. In older systems, we will be able to run only one program at a time, but as the evolution of the computer system, it has extended, we can have n number of applications which are having, that is, n number of processes can be run at the same instant of time. So this is the best example. You can see this from the task manager itself, and how much amount of CPU is being allocated for each and every process. For memory, how much memory is allocated, and the disk storage, what is the network speed, everything is being shown here. So in task manager, if you see the task manager, what are all the tasks available, what are the applications we are currently using, and what are the how many number of processes are being created or associated with the particular application, it can be shown here. So this we can easily view in your system also. And for viewing what are all the threads associated with these processes, we are in need of a separate application that we can see when we discuss about the threads. And going back to our lecture, so this is what a process is. So there are different states in which a particular process can exist. So state, in the sense, the different um, activities, or different stages at which a process can exist in a particular computer system. So that is called as a state. So the state of a process is defined in part by the current activity of the process. Currently, what is the actual state of the process, or where it is actually in. So that is known as the state of a process. So usually any process, whatever may be the number, each and every process, it will be in any one of these five states. That is, either it will be in a new state, or the ready state, or the running state, or the waiting state, or the terminated state. So what is called as a new state? So new state, whenever we create a process, that is, if the process is being created, at that time the process is said to be in the new state. That is, a program is being converted to, when it starts its execution, it becomes a process, right? So whenever a process is being created, we say that the process is in the new state. And when the process is waiting for a particular processor, that is, if it is ready to get its processor for execution, that is, it is ready to do that job, in that case we say that the process is in the ready state. And once after giving the place for the process to run. That is when the process is being given to the processor for its execution. So the instructions are being executed one after the other, because we know the program is a set of instructions. So one by one, when we start executing those instructions, so at that time the process is said to be in the running state. And if suppose a process during its execution is in need of some of the input output devices, or it needs to receive a trap signal, or some other higher priority processes are in, at that time it has to go to the waiting state, to the back to the ready queue. It has to give the hold of the processor to some other process, and it needs to wait for certain amount of time. At that time we tell that the process is in the waiting state, and after the completion, automatically the process must get terminated, and at that time the process will finish its execution. So such a state is called as a terminated state. So at one instant of time, only one processor it can be able to run. So and all the other processors will be waiting. So if every process, it will be in any one of these five states, and this is the state transition diagram. And this diagram, it clearly explains how the processors are getting inside the processor, and it is being executed, and at which time, at which stage it will be. For example, at first the process is in the new state, and then when it is admitted to the processor, it will be ready for its execution, so it will be in the ready state. And once after it gets the processor, it will be shifted from the ready queue by the scheduler. The scheduler will dispatch the process one by one from the ready queue to the processor, and it will convert its state to the running state and will start its execution. And during the time of execution, if the execution does not need any other further resources, and it after smoothly executing, it will exit from the processor and it goes to the terminated state. Or if suppose if it receives some other higher priority process, it comes inside the processor, it requests for the processor. At that time, this process which is currently running inside the CPU, it will be interrupted, and again it will be going back to the ready state. And if suppose the currently running process is in need of any IO device or any other resources for its execution, it will be suspended temporarily, and it will be sent to the waiting state. And after the waiting state, once again after the completion of that particular activity, that is IO event or any other completion of resources, it will be again sent to the ready state, and then again the scheduler will dispatch it to the processor. This is how this state transition happens. So here we want to note very important thing to note is that after the completion of the IO event, once again the processor should go to the ready state, and then only it can be handled to the processor. It is not possible for the process to directly come from the waiting state to the running state. So this is of most importance. This point is of most importance, and only during the interrupt we are need to move the process from running to ready state, or otherwise it can smoothly terminate. So these are the different process states available in a particular system, and all the processes will be in any one of these five states at any instant of time. And every process, it will be having its own process control block. This process control block is also called as a task control block. So process control block, it holds what are all the entities of a particular process, that is the details about a process, or how a process is being executed, or what are the entities associated with that process. Everything can be shown in this process control block, and every process, it holds its own process control block. So we need to know what are the things which are present in a process control block. So first, the process state is present. That is, we have seen any process will be in any of the five states, that is new, running, waiting, execution, and termination state. So any process will be in any of these five particular states at a particular instant of time, right? So the particular state, that is the current state of the process, will be present in the process control block, and the process ID, it's not mentioned here. The process ID, it will also be present. It is a unique ID that is exclusively mentioning what that process is, what is the number of the process that is, it is unique to that process alone, right? So next is a program counter. So a program counter, why the program counter is necessary? Because the current execution which is particularly getting executed now in the processor, and the next instruction that needs to come, the address of that instruction will be present in this program counter, right? So next are the CPU registers. So what are all the registers associated with that process? So it can be an index register or a stack register or general purpose registers. So all these registers together, put together, we can say it as CPU registers, as CPU registers. So these registers are also associated with every process. And then comes the CPU scheduling information. And so at one instant of time, we can have only one process that is getting its execution done. So we need to prioritize which process should be given to the CPU and how long it should hold the CPU, so that the task can be completed without any interruption. Okay. And for higher priority processes, sometimes the execution time will be more for higher priority processes. At that time, the waiting of the other processes, it can be very long. So we need to do that scheduling properly. So such type of scheduling information is also available in the process control block. And then comes the memory management information. So memory management information in the sense how much amount of memory does this process holds. So such type of informations will be available in the PCB. And the accounting informations, what are all the resources that the process holds, for example, the total amount of time it takes, and what are the account numbers, and how much time limit is left over. All these informations are it is present in the accounting information. And then comes the IO status information. So what are the list of input output devices which are allocated to that particular process, that will also be available in the PCB. So these things, all these criteria are mentioned in a process, for a process, in that process control block. So this is how, if suppose any interruption occurs during the execution of the process, at that instant of time, the process which is being executed, that process unique ID, it will be saved. And then this context switching happens. We know what is context switching. That is switching from user mode to kernel mode for the purpose of getting some resources that is needed by the process. So at that time, the currently running the executing process, it has to save its state, and then only it has to switch from one mode to the other mode. And after the completion of that resources, or the utilization of that resources, and after releasing all the resources, again it has to hold back to the previous state. So at that time, we must know which state is the last but one state, right? So at that time, we need to get that information from this process control block only. So when CPU switches to another process, the system must save the state of the whole process and load the new process state. So this is known as context switching. But usually we will, as a good for a good performance of the system, we need a very less context switching, because a context switching overhead should not happen. It should not be too large, so that we need to have very less number of context switches. So this is these are the different entities which are available for any particular process, and this is how a process control block looks like. In addition to this, there are many other criteria also associated with any process. So this is the end of we have just seen an introduction about what is a process, and what are the different states of a process, and what is known as a process control block, and what are the different criteria that is associated with all the process. And with this, we can end today's lecture, and we can catch up with another one topic in the next session. Thank you.